Good morning, students. In the previous session, we discussed about LL1 parsing, and we know that there are three steps to construct LL1 parser. The very first step is computing the first and follow that we have successfully done in the last session, and later we learned how to construct this parsing table also. I hope you remember this, the construction of parsing table. If you all are remembering, I will move on to the third step. Otherwise, let us do the second step once again. Please message me in the chat box. I'm just waiting for your reply. So shall we move on to the third step now? Okay. Okay, Lakshmi has requested me to repeat again. Most of them have told me to continue. So Lakshmi, anyhow, we are doing one more problem. That time we see it, okay? Otherwise, I will repeat for you once again. Okay, now everyone must have this parsing table in your notebook. Looking into the parsing table only, we are going to learn the parsing of the string. So take down the question, parse the string ID plus ID dollar. Parse the string ID plus ID dollar. Before that, we just see the diagram of LL1 parser. Looking into the diagram, what do you feel? See, this is similar to push-down automata, right? This is the input tape, this is the control unit, and of course we have the stack. We know what is the output given by this push-down automata. What the push-down automata says, either it recognizes the string or it does not recognize the string. Either it accepts or rejects, right? So this is the control unit, which is equivalent to the CPU of today's computer. This is according to the algorithm. From the table, it picks or selects the rule from the grammar to parse the given string, whatever is kept in the input tape. This input tape only, we called it as input buffer in our lexical analysis phase. And we also learned that how to effectively implement the input buffer through buffering scheme, right? Okay, now that input buffer only here being given as input tape. In LL1, the first L, what does it indicate? Left to right scan. Of course, the parser is scanning the input, scanning the string from left to right, character by character, and dollar indicates the end of the string. The second L stands for leftmost derivation, isn't it? So this is the diagram for LL1 parser. It is similar to push-down automata. That is why we call the implementation of parsers are nothing but push-down automata. And to recognize the syntax of the programming languages, we use context-free grammars. Okay, now let's move on to the parsing table. All of you, please draw this parsing table in your notebook. I just give you the time. In fact, these three columns are enough, but the fourth column, just for the sake of understanding, I have included. The first column gives you the contents of the stack. The second column gives or mentions the contents of the input tape or the input buffer. And the third column must be parsing action. In fact, I have included one column just for the sake of understanding. Please, all of you, note down this. Then only we are able to do. When I explain the step, you people also continue to do in your notebook so that it will be easy for you. So I hope you have copied the table. Okay. What is the initial content of stack? Initial content of stack, the bottommost symbol is dollar. After that, the start symbol of the grammar is pushed onto the stack. So what is the start symbol of the grammar? It is E as per the given grammar. So what is the string available in the input buffer? Now we are going to parse the string ID plus ID, and the end is marked by the dollar symbol. Right. Okay, now how the parsing begins. Every time the parser checks what is available at the top of the stack and what is the input symbol it reads currently now. Currently, the input pointer is pointing to the very first terminal, which is ID. Right? So let me write it here. The top of the stack is E, and the input symbol, what it is reading from the input tape is ID. So go to the table, parsing table, E comma ID, and check what rule is available there. So let us go and check. When I checked E comma ID, the rule available is E derives TE dash. So that is the action to be taken by the parser. So what is the parsing action it will take? Now, in the stack, in place of E, it is going to replace with TE dash, right? But while replacing with TE dash, first it will push E dash, then followed by T. T appears at the top of the stack. So carefully observe this. Now T appears at the top of the stack. So input buffer remains the same. So let me copy and paste it as it is. All right. Now tell me what is available at the top of the stack and what is the input symbol it is reading. Top of the stack contains T. Still it is reading T comma ID. When I go to the table again and check what is there, what is the entry at the cell T comma ID, it is nothing but the rule T derives FT dash. So already I have written here T derives FT dash. Now what is the next step we have to do? So as of now, this is the content of the stack. In place of T, we have to replace it by FT dash. Again, while replacing it, first to push T dash onto the stack followed by F. Still, the input buffer contents remains the same. Now, which two symbols the parser is looking for? The top of the stack, which is F, and the input symbol, what it is pointing to. Still, it is pointing to ID. Sorry, it is not T, it is F. F comma ID. Now, let me go to the table and check the rule. What is F comma ID? It is nothing but F derives ID. So this is the rule the table says. Now, you know what we have to do here, right? In place of F, replace it by ID. Remember, ID is a single terminal symbol. Don't try to reverse it. First to push D, I, it's completely a wrong thing. ID put together is a single terminal symbol. Right, now let me retain the input buffer as it is. Now check what is available at the top of the stack and what is the content of input buffer. It is the same, ID comma ID. When the top of the stack and the input symbol becomes the same, what we need to do? Pop whatever is available at the top of the stack and at the same time advance the input pointer to point to the next symbol. So this is the action taken by the parser. So what will happen at the next step? Now let me copy this as it is. See, first column, remember it is the stack content. The second column is the input buffer. So I have to take the action, right? The top of the stack is to be popped. Since match found, now the input pointer is pointing to the next symbol, which is plus. Now plus is the symbol currently pointed by the parser. It is reading plus in fact. Okay. So which two symbols the parser is referring now? It is checking at the top of the stack T dash and the input buffer says it is reading plus. So now go to the parsing table and check what is the rule available at the cell T dash comma plus. So T dash comma plus says that the rule to be selected is T dash derives epsilon. So copy it here, T dash derives epsilon. So what is to be done? In the stack, dollar is there, E dash is there. Now this T dash must be replaced by epsilon. If it is replaced by epsilon, T dash is vanished, isn't it? So this is the content of this stack. Still, the parser is reading the plus symbol now. Now, which two symbols the parser is looking for? One is E dash, another one is plus. Okay, now go and check what is the rule available at E dash comma plus. At E dash comma plus, the rule available is E dash derives plus T dash. So let us write the same rule here in the parsing action call. Now you know what is to be done. The stack is containing dollar as well as E dash. In place of E dash, we have to replace whatever is available on the right hand side. So what is available on the right hand side? First you need to push E dash, followed by T, then followed by plus. And the string is plus ID dollar. Right. Now you check the top of the stack and the input symbol. It is one and the same, right? Plus as well as plus. If both the symbols are the same, what is the parsing action to be taken? The pop of the stack is to be removed. Since match is found, the input pointer is advanced to the next symbol to read. What is the next symbol it will be reading? It will be reading ID now. So you need to write the parsing action, whatever I have given in the sentence there, that you need to fill here. While when you are writing the answers in the notebook. So let me copy it here. You have to clearly mention what is the parsing action we are taking at each and every step. Okay, now what is the content of stack? It is containing dollar, it is containing E dash, it is containing T, but plus is removed from the top of the stack. Still in the input buffer, these are the symbols the parser is yet to read. Or I can say the input pointer is pointing to ID currently now. So the two symbols what the parser is looking for, T comma ID. Go to the table and check what is the rule for T comma ID. T comma ID, the rule is T derives FT dash. The rule is T derives FT dash. So I have copied the rule here. Now you know what is to be done in the stack. The stack contains dollar, E dash. In place of T, you push FT dash, that too in the reverse order. So first you push T dash, then followed by F. ID dollar. Alright. Now we have to check for the combination F comma ID. We have already checked, which will allow us to select the rule F derives ID. So now at the next step, the F must be replaced by ID. If you replace F by ID, now the input symbol and the top of the stack matches. So the parser is looking for two symbols, which is ID and ID. Now in this case, once again, it is going to pop the top of the stack and the input pointer is advanced to point to the dollar symbol. So now the stack contains dollar, E dash, T dash, ID is removed from the top of the stack, and now the input buffer is containing dollar. Input buffer in fact contains the complete string. The read write pointer is pointing to dollar as of now. Now you check for the rule at the cell T dash comma dollar. So what is the rule available? T dash comma dollar. So T dash comma dollar allows us to choose the rule T dash derives epsilon. T dash derives epsilon. So you know what is to be done. Now T dash must be replaced by epsilon. It means T dash is removed from the top of the stack. Now you go for the rule E dash comma dollar. E dash comma dollar. I think E dash comma dollar is also allow us to select the rule E dash derives epsilon. Right. So when you take the action as per the rule, E dash is also vanished. So what is available at this stack? Only dollar. What is a symbol pointed by the read write pointer? It is dollar. In the stack as well as in the input buffer, if both are dollar dollar, then it means the parsing is successful. In the last column, you clearly mention the parsing is successful. I think you have understood this. Okay, students, it is once again I'm explaining how to fill the LL1 parsing table first, then later we go for parsing of the string. All right. While constructing the LL1 parser, the very first step what we have to do is computation of first and follow, isn't it? That we have seen many examples. Now once again we repeat how to do this filling of LL1 parsing table. Remember, this is the signature for this table. If you remember this, then entire rows and columns you can easily remember. M refers to the machine. Machine here is what? Parser. Row is given by capital A and column is given by small a. So capital letters where we will use to represent the variable, and the small lowercase letters we use to represent the terminal symbols. So in the grammar, it is representing E, E dash, T, T dash, F. These are the variables we have, isn't it? This is the grammar. And the terminals are ID plus star, open parenthesis, close parenthesis. Don't consider epsilon as a terminal in parsing table. Please note the point. And you have to include a dollar also, because dollar is a right-hand marker of the string. Okay, now let us go rule by rule. What is the first rule given? E derives TE dash. Now we are supposed to fill this rule into the parsing table, but where? That is a question, right? So when you consider this rule, first you check what is first of E. What is first of E? It is nothing but open parenthesis as well as ID. It means at the cell E comma open parenthesis, E comma ID, we have to fill the rule E derives TE dash. You see here, E comma open parenthesis and E comma ID, we filled the rule E derives TE dash. Now let's move on to the second rule. Actually, E dash has two alternatives. Let us consider it as two rules. One is E dash derives plus TE dash. Another one is E dash derives epsilon. So let us consider only this rule, E dash derives plus TE dash. So try to find what is first of E dash from this rule. From this rule, first of E dash is only plus, right? So E dash comma plus, you enter the rule E dash derives plus TE dash. At the same time, we know that E dash produces epsilon. There is a rule E dash derives epsilon. Where to fill the rule? Because we don't have epsilon as a column. Epsilon cannot be treated as a terminal when you are filling the LL1 parsing table. So whenever there is an epsilon in the first set, go to the follow set. What is there in the follow set? Dollar as well as close parenthesis. So E dash comma dollar, E dash comma close parenthesis, you fill the rule E dash derives epsilon. I hope you would have understood this. If you have understood, please reply in the chat box. I'll wait for some time. Okay, now let's move on to the third rule. T derives FT dash. Where will you be filling the rule? Find first of F. What is first of F? It is nothing but first of T, in fact. Open parenthesis and ID. So T comma open parenthesis and T comma ID. That is the address of the cell. There you fill the rule T derives FT dash. Right. Now, consider the next rule. T dash derives star FT dash and T dash derives epsilon. In fact, there are two rules, right? So consider only the rule T dash derives star FT dash. Here, the star is the first symbol produced by this. So T dash comma star, you have to fill the rule T dash derives FT dash. Of course, we are done. At the same time, T dash produces epsilon, right? Whenever T dash produces epsilon, which set of symbols we have to go for? We have to consider the follow set. In the follow set, what are the symbols available? Plus, dollar, close parenthesis. So T dash plus, T dash dollar, T dash close parenthesis. At these cells, you enter the rule T dash derives epsilon. And the last rule, what we have? F derives E. F derives E. When you try to find out first of F for this rule, what we obtain, it is nothing but open parenthesis. So F comma open parenthesis, you need to fill the rule F derives E. And F comma ID, you have to fill the rule F derives ID. I hope you have understood this. If so, please reply in the chat box. Then we will move on to the next problem. I think in the last class, I have told you to compute the first and follow of this expression grammar, right? Have you tried? I have given the answer. Have you done it, verified it? Okay. Okay, nice. If you are actively doing, very nice it is. Okay, now take down this question. Take down this question. Check whether the given grammar is LL1 or not. You will be getting the questions like this. Check whether the given grammar is LL1 or not. So to check, the very first step you have to compute first and follow. Take down the steps. You have to compute first and follow. And then you have to build the parsing table. After building the parsing table, if any of the cell contains more than one entry, then for the given context-free grammar, we cannot construct LL1 parser. We have to go for some other type of parser. Or else I can say the given grammar is not LL1 parsable. Is not LL1 parsable. Have you understood? Let me repeat. If the question comes like this, first you need to compute first and follow. The second step, you have to build the parsing table. After building the parsing table, if any of the cell or one or more cells also may contain more than one entry. If it is so, the given context-free grammar is not suitable for LL1 parser construction, or it is not LL1 grammar. The grammar is not suitable for building the LL1 parser. Right? So take down this problem. Try to find the first set. I will also do along with you. Those who have not completely understood can continue to listen, or you can continue to do and later verify the answers. Okay. First of yes. For yes, there are two alternatives. Look into both the alternatives and what is the first symbol you see. In this alternative, I is the first symbol. In the second alternative, A is the first symbol. Both are terminals. So directly enter first of A is I comma A. Remember, terminals must be written in lowercase and the non-terminals or variables must be written in uppercase. Okay, now tell me what is first of S dash. It is very simple, right? It is E. Another one is epsilon. Since already there is a terminal E in place of epsilon, I have no choice. I have to use this symbol now, which is epsilon. So E comma epsilon, right? What is first of E? Very simple. You can easily identify. It is B. While writing the first set, write within the set brackets. Don't miss this curly braces. You have to write within the set brackets because we call it as first set as well as follow set. Okay. Now, let us find the follow of yes. Follow of yes by default contains the dollar symbol, isn't it? Every start symbol of the grammar, by default, we have to include the dollar symbol as the follow set symbol. To find follow of yes, we have to select the rule which has yes on the right hand side. So this is a rule we have. Yes derives IET yes yes dash. So let us try to match with the given format. Yes derives IET yes yes dash. So yes must appear here because we are trying to compute follow of yes. So that should be matched with B. Beta is S dash. Before that prefix whatever appears is nothing but alpha. IET. Right? So this is the way you have to match the rule. Now tell me what is follow of yes. Follow of yes is, there is a symbol in fact right after following yes. So how do you write the rule? It is first of yes dash. What is first of S dash? We have already identified and kept. The first of S dash is E as well as epsilon. So let me copy and write E as well as epsilon. I'll just drag this table below. E as well as epsilon, but the follow set cannot contain or cannot include epsilon, right? So what do? E can be included in the follow of yes, but epsilon cannot be included. So what do you need to do? First of S dash contained epsilon, right? So replace this S dash by epsilon. If you replace this S dash by epsilon, this is the rule we are getting now, right? It is in the format A derives alpha B. Whenever the rule is of the format A derives alpha B, this is the third rule, right? So for the third rule, how do you compute follow of B? Follow of B is nothing but yes here, which is nothing but follow of A. So follow of B is follow of A. In this case, follow of S is follow of S itself. So there is no change. So what is the symbol to be included? Only E is to be included as a follow of yes. So let us include here. Okay. Now let us compute follow of yes dash. To compute follow of yes dash, once again, yeah, we have to consider one more rule. Sorry, yes dash derives ES to compute follow of yes, isn't it? So let me write that rule here. S dash derives ES. Because this rule also contains S on the right hand side. When I explore this rule, according to this rule, what is the formula? Third rule can be applied. Follow of S is follow of S dash. That is a rule I will obtain, isn't it? Follow of S is follow of S dash. As of now, there is no follow symbols we have computed for S dash. So this rule is pending as of now. So you remember this rule, later we have to update. So now I will underline this rule. Since we do not know what is follow of S dash, I cannot update furthermore in follow of S. That is what I tried to say. Okay, now let us compute follow of S dash. So we are going to find follow of S dash at this moment. To compute follow of S dash, I have to consider the rule S derives IET S dash, because this is only one rule which contains S dash on the right hand side. So let us consider the rule S derives IET yes. Everything becomes alpha and S dash should be matched with B in your rule, right? So if this is the rule, how do I compute? How do I found it? Follow of S dash is equal to follow of S. That is what the rule says, right? Because after S dash, there is no symbols following it. So when there is no symbol following it, you have to go for the third rule. So follow of S dash is equal to follow of S. So let me write the rule. follow of S dash is equal to follow of yes. So how do I update it here? I just copy and paste it here. Control C and Control V. Now, if of course, after computing follow of S dash, we can I update follow of S also, but there is no change. We have exercised both the rules, right? So furthermore, there is nothing to exercise. So let me remove the underline now. So we have computed follow of S dash also. Now we have to compute follow of E. For that, I don't need to exercise any rule. From the production rule only, I can find it out. This is the only rule which contains E on the right hand side. After E, you check what is the symbol following it. It is a terminal symbol. If it is a variable symbol, then you have to do some further steps. If that is a terminal symbol, there is nothing much to think. So follow of E is nothing but T. So that's all. We have found the first as well as the follow set for the given problem. Is there any doubt for you people? So you start filling the parsing table now. Rows represent the variable and the columns represent the terminal symbol. Apart from the regular terminal symbols, you have to include a dollar also. Don't consider epsilon as a terminal symbol in the parsing table. And epsilon should not appear in the follow set also. Remember both. Okay, those who have not understood can follow my instructions to fill the table. So consider the first rule. S derives IET SS dash. Only consider that rule. From this rule, tell me what is the first of S. First of S is what? It is I. Isn't it? Actually, first of S is two symbols. One is I, another one is A. But you have got I from the rule IET SS dash. So consider only that rule. Now I have to fill this rule in the cell S comma I. I have to fill this rule in the cell S comma I. We have another rule S derives A. First of S is A for that rule. So S comma A, I can fill the rule S derives A. Alright, so it is done. Now let's move on to the second rule. S dash derives ES and S dash derives epsilon. We have two rules. First, consider only S dash derives ES. When I consider this rule, and if I try to find what is first of S dash for this rule, it is only E, right? So S dash comma E, you have to write the rule. S dash derives ES. So S dash comma E, I will fill the rule. S dash derives ES. And of course, we have another rule, S dash derives epsilon. It means first of S dash is epsilon. Whenever first set contains epsilon, go to the follow set. What is the follow set of S dash? It is S dash dollar as well as E. So at the entries S dash comma dollar, S dash comma E, you have to write the rule S dash derives epsilon, isn't it? So let me copy only this epsilon right now. So I have to fill here S dash derives epsilon, and the same rule is to be updated here also. So let me copy this epsilon and write it here. Yeah. So one more rule is there, I think. Yeah, E derives B. We know where to fill it. E derives B is to be filled in the column E comma B. parsing table is built. Now, from the parsing table, we can easily identify that it is not an LL1 parsable grammar. So, how do you write the conclusion? You write the conclusion in such a way that in the parsing table, in M of A comma A, you have to write the conclusion like this. In M of A comma A, it means in the table, the cell. So what is the address of the cell here? It is M of S dash comma E. S dash comma E contains more than one entry. Contains more than one entry. Hence, the grammar is not suitable for LL1 parser. Or it is not LL1 parsable. This is a conclusion you have to write. Then only the answer is complete. So compute first and follow sets. From the grammar, you can easily identify first of S is first of A, which is A. First of A is also A itself. Now let's compute follow set for S. By default, for the start symbol, you have to include dollar. But further, we don't have any rules which contains S on the right hand side. So follow of S is only dollar. What is follow of A? Directly from the rule itself, we can identify. This is the only rule which has A on the right hand side. If there are no symbols following A, when there are no symbols following A, just go to the head of the production rule. Follow of A is follow of S itself. So follow of A is also dollar. I hope everyone would have come to the same conclusion, isn't it? Now build the parsing table. Now build the parsing table. So to build the parsing table, first we have to, of course, construct the parsing table. So what is the signature of the parsing table? The name of the parser is M. Row represents the variable. Column represents the terminal. So row must contain S as well as A. The column must contain what are the terminal symbols present here. The L1 is by default, you have to include the dollar symbol. So this is a parsing table we have, right? So now consider the rule one by one. S derives A. Where do you fill this rule? At the first of S, isn't it? So S comma A must contain the rule S derives A. Alright? Okay, S derives terminal A. Where do you fill this rule? That also you have to enter into the same cell. S derives A. Right? Now where can you fill the rule? A derives A. Go to the first set of A, which is containing A. So A comma A will be containing the rule A derives A. Since the cell S comma A is containing more than one rule, this grammar is not LL1 grammar. This grammar is not suitable for the construction of LL1 parser. So I have given a very simple example to understand it. I hope you all have understood it. So what is first of S? First let us consider only this rule, AAAB. First of S is first of A. but A could be replaced by epsilon, isn't it? If A is replaced by epsilon, first of S contains A. Now go to the next rule. From this rule, what is first of S? First of S is first of B, but B produces epsilon. If B is replaced by epsilon, first of S is B. Tell me what is first of A. First of A is nothing but epsilon. First of B is also epsilon. Right? I hope all of you have derived to this conclusion. Yes, most of you people have computed it. Now tell me what is follow of yes. Follow of yes, by default we have to include the dollar symbol. Apart from that, there is no symbols available in follow set of yes, because there is no rule which contains S on the right hand side, isn't it? So follow of yes contains only the dollar symbol. Now you have to compute follow of A. Computing follow of A is little tricky, right? You have to consider this rule. When you consider this rule, A is available at two places. First, consider this A. What is follow of A? It's a terminal symbol which is A. But when you consider this A, follow of A is nothing but B. Isn't it? Similarly, try to compute follow of B also. When you compute follow of B, you have to consider this rule, BA. After the first B, there is a terminal symbol B. After the second B, there is also a terminal symbol A. So follow of B is the same as follow of A, in fact. So let me copy and paste it. Yeah, whether it is B comma A or A comma B, it is one and the same. Now go for the construction of the parsing table. Go for the construction of the parsing table. Let me copy the same thing. Right, so what are the variables we have? We have three variables, right? One is S, A, and another one is B. What are the terminal symbols we have? A, B, and we have to include the dollar also. A, B, and we have to include the dollar symbol also. For that, let me include a column. Right, now you can begin the construction of the parsing table. Consider the rules one by one. S derives AB. This rule gave the first symbol as A. So you have to enter this rule against the cell S comma A. From this rule, the first of S, what we got is only the terminal A. So you have to fill the rule here. Right? How do we derive this B, first of B? This first of S as B, we got it from the other rule, S derives BA, right? So let me copy that rule here. Control C. I have to enter this rule in the cell S comma B. I think you have understood this, right? There is no confusion. From this rule, we obtained the first of S as A. From this rule, we obtained the first of S as B. Accordingly, we have segregated the rules and we have filled in the table. Now, what is the second rule we have to fill? A derives epsilon. So, first of A contains epsilon. Whenever there is epsilon in the first set, we have to go for the follow set. So, what is the follow set of A? It is A as well as B. So, A comma B, you have to fill the rule A derives epsilon, right? So, control V, I'll copy it here. Here also I have copied A comma B, I filled with the rules A derives epsilon. Similarly, B derives epsilon. Where do you fill it? In the follow set of B, which is A comma B. Yes, we built the parsing table. Once we built the parsing table, what is the conclusion you people are arriving at? This grammar is LL1 parsable. For this grammar, we are able to construct LL1 parser. So now, lastly, you take the question, parse the string for the given grammar. Take down the string. It is nothing but A, B. When the grammar is LL1 parsable, it is possible to parse the given string also, right? So parse the string, construct the parse table. The third step you have to do for the string A, B.